everybody. Welcome back to our discussion of I keep almost saying triangles. Our discussion of circles and the angles that are inside of them. So in our last video, we talked about central angles. And here's the definition that we used. We said that a central angle is an angle where its vertex is in the center of the circle. And then the two sides are radii, so they go out from the center to the circumference of the circle, to the outer edge of the circle. And we know that that looks something like this. So in this particular example here, I made a 90-degree angle. Okay. So we also learned that when you have a central angle, that means that it's going to create these arcs, right? In other words, it's going to take the circumference and it's going to divide it into chunks. Okay. So this 90-degree this 90-degree angle creates an arc, right? Because it cuts out this piece of the circumference. And we know, goodness, I just cannot trace the edge of the circle, can I? And we know that if you have a central angle, the size of that arc is going to be the same as the central angle. So if we say this is a 90-degree angle, then if you go to the endpoints of that angle on the circle and trace out the arc, that's a 90-degree arc. Okay, so that was the last video. What we want to talk about today is a different kind of angle that we see in circles, and that is this guy right here, the inscribed angle. Okay. Based on the name, you can probably tell it's not in the middle anymore, right? Central means center. This guy is not in the middle anymore. An inscribed angle, instead of having its vertex in the center, it has its vertex somewhere out here on the edge. Its vertex is on the circumference of the circle. So an inscribed angle looks something like this. So notice here, this is really important. This inscribed angle that I drew here, I want you to notice that it's got endpoints here. And it marked off the same exact arc that this 90-degree angle did. But I want you to notice something about this inscribed angle. It's much smaller than this 90-degree angle. Because it's moved back, see this? The vertex of this 90-degree angle is much closer to the arc than this is. And so when you follow this angle back, all the way to the edge, it goes a long time before it hits the circle, and so it tends to open up more before it gets there. So look at this. The same 90-degree arc was made by this 90-degree central angle, but also by this inscribed angle, which is much smaller. It's not just smaller either. It's a special kind of smaller. It is exactly half of that arc, which is kind of neat. So if you know that you have a 90-degree arc here, you know there's a 90-degree central angle that creates it. There's also a half that, or 45-degree angle that is inscribed. So anytime you see a central angle creating an arc, you know the measure of that angle is the same as the arc. Now, when we see an inscribed angle creating an arc, we're going to know that in order to figure out how big the arc is, we have to double that inscribed angle. Okay. Let's go up here. All right, so let's take a look at another kind of interesting piece of this. If you look at the second circle in the middle, I drew a diameter across the center of it, right? So we know from our earlier definitions that the piece above there, up here, this is what we would call a semicircle, and the piece below it would be a semicircle. Semi meaning a half a circle, and we know that semicircles are exactly 180-degree arcs. So this arc right here, I know for a fact is exactly 180 degrees because it's a semicircle. So look, here's the central angle that's creating that 180-degree arc. It's a 180-degree angle creating a 180-degree arc. But watch this. I'm going to create a inscribed angle that's going to create that same 180-degree arc. Now let's think about this. the inscribed angle is going to be smaller, and it's not just going to be regular smaller, it's going to be smaller by half. So the angle, an inscribed angle that creates this arc, is going to be half of 180, or exactly 90. So look at this cool angle, right? Again, if you put the angle in the center, you put a 90-degree angle in the center, it's going to create a 90-degree arc. But look what happens when I take that same 90-degree angle and I put its vertex on the outside. I make it inscribed instead of central. Instead of, when it meets the sides of the circle, instead of it creating a 90-degree arc, it creates exactly double that. It creates this 180-degree arc. All right, so let's see if we can use that the other way around. So if I have this picture, this circle, right, they told us this is 60 degrees. Okay, well, this is an inscribed angle. So if this angle is 60 degrees, I can follow this angle out. There's an endpoint. There's an endpoint. That means this arc that 60-degree angle creates isn't going to be 60. It's going to be 120. It's going to be twice that. The inscribed angle is always half the arc. Central angle always matches it exactly. We're going to use this a lot more in the next lesson, but right now it's just kind of a fact about inscribed angles. So let's see if we can identify some inscribed angles, and then we're going to look at some of those bigger diagrams and name all the parts that we know so far, because inscribed angle is the very last one that we have to talk about. Okay, so what I would like you to do is take a look at this diagram and see if you can find any inscribed angles. So remember, when we're talking about an inscribed angle, we are no longer talking about angles that have their vertex in the middle. We are talking about angles that have their vertex on the edge. So for example, there is a vertex right there. There's two lines come together. This angle right here is going to be an inscribed angle because it has its vertex on the edge of the circle. There are a bunch more inscribed angles in here. Go ahead and try to identify some of them. Okay, so hopefully you were able to choose the angles that were inscribed. So let's take a look here. Again, here at vertex L, we said we had an inscribed angle. So I can follow out to get the other points. So C and N. Right? So C, L, N. That's got to be an inscribed angle. Now, over here at V, there's no vertex, right? There's just one line, but there's no vertex. So there aren't any angles there. Up here at N, though, yeah, there's an angle right there, right? So let's follow it. S and L. So, listen. Is this technically an inscribed angle? Sure it is, right? Because its vertex is on the, its vertex is on the circumference of the circle. Now, I'm asking that because look, it comes all the way out and touches the circle here, but on this side, it doesn't, right? But I could, if we continued this, it would create an arc on this side. So that's technically still an inscribed angle. So I'm going to call it S and L. Right? As long as N is in the middle, I'm good to go. Right up here at J, we have another one, right? So again, it's just like this one here where it centers back to here. The important part of the inscribed angle is that its vertex is on the edge or the circumference of the circle. So I have another inscribed angle here. So that's CJS. Or you could call it SJC as long as you've got the J in the middle. So J is the vertex. Okay. Now over here at C, I'm going to clean up my diagram a little bit. We have more than one inscribed angle over here at C. Somehow managed to. All right, so let's take a look here. If I go look at this angle right here, That's an inscribed angle, right? It goes from J to C to S. So angle JCS. I could also look at this little angle right here. Okay? You could call that one LCS. I could also look at them together, like this whole big angle, right? That would be JCL. So there are actually 3 inscribed angles at this vertex. See, but if you're looking for inscribed angles, always, 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 you should be around the outside of the circle on the circumference, looking for points of angles, right? It doesn't matter if the sides go to the edge or if the sides go to the center. It just matters that their vertex is on the outside of the circumference. All right. So let's take a look. I'm going to take a look at a couple problems like this. So you may notice this is all the circle vocabulary that we have talked about to date. We've had, these were kind of the first day, and then we talked about arcs and central angles, and now here we are to talk about inscribed angles and wrap it up. Okay, so what we're going to do here is we're going to see if we can find these things in this diagram. So I'm going to go through a couple of these with you, and then you're going to have a couple to do in Schoology to practice. All right, so center of the circle. If I want the center of the circle, I go to the middle, right? Middle of the circle, there it is. The center of the circle is always going to be just a point. Now, in this particular circle, it's labeled. Awesome. It may not be labeled in every diagram. If it's not labeled, then we can't name it. Right? Doesn't mean it doesn't exist. It just means we can't name it.
Or are they sanitized?
They have not been sanitized.
And assigned to
nope.
children already.
This girl does not understand what recording means.
Oh.
It's altered ice. We have to be interrupted. Okay, so anyway, back to my originally scheduled programming. The center of that circle is A. So if we're looking for a radius, we need to go to the center and find a line that takes us out to the edge, right? So A is the center. I can follow this line out to the edge. That would be AF. Or I could follow this guy out to the edge. That would be AH. And interestingly, if you put them both together, you get yourself a good old-fashioned diameter, so we might as well write that right there too. HF, a diameter. Okay, let's see if we can find a chord in this diagram somewhere. Right? Remember, chords have endpoints on the outside or the circumference of the circle. So I'm looking for points on the circumference of the circle. There's one D, there's one G. Look, there's a segment that connects them. DG, you're a chord. Now, are there any other ones? Sure. Look here. I could go from C to D. HF is technically still a chord. Why not? Okay. Secant line. Remember, we just call it a secant sometimes, but I like to call these tangent lines and secant lines because it reminds me that they are lines. They're not segments. They don't end at the circle. They keep going, right? So if I want a secant line, I'm looking for a line that cuts through my circle, goes through the middle, right? Goes through the interior of my circle. That would be this guy right here. See this line here, BD? He cuts through the circle. So that's a secant line. And then remember our tangent, he's kind of like a secant, but he doesn't cut through. He just kisses the edge and keeps on trucking. So that would be this line here. Maybe you could call him BJ. Maybe you could call him BH, whatever makes you happy. We also know that if you have a tangent line, that point right there where it kisses the circle, we call the point of tangency. Right? So that's all our stuff from the other day. Then we learned about all these central angles and arcs and all that business, right? So let's see if I can find a central angle. When I go to this diagram, if I have a central angle, then it should be centered. It should have its vertex in the middle, right, at the center. So let me go over here. Here's the center. Right? I don't see a whole lot of lines leaving the center here, but I do see this AF and AH. So technically that's a central angle, right? So angle HAF, okay, is central angle. I also have an inscribed angle up here, CDG. CDG. Okay, now, as far as arcs go, you can pick any arc that's less than 180 degrees for a minor arc, right? So all I need is 2 points that create an arc. So D over to C, that's a minor arc. Or H to G, right? That's a minor arc. No big deal. Okay, if you want a major arc, then you've got to go past a point and around, oh, I didn't mean to erase everything, and around the way. So let's see here. BH, that's a minor arc, right? If I want the major arc, we're going to go around the long way. So instead of just BH, I got to put a point in the middle to let them know you need to go the long way, right? How about BDH? Any of these points over here will do. Right? You could say, hey, look, DF, that's a minor arc. So if I want someone to go the long way, make a major arc, instead of just DF, I'm going to put a letter in the middle. So maybe DBF or DHF. That lets them know they need to go the long way. Okay? So your job in Schoology is to look at some more diagrams like this and name all the parts that you can. All right? Put any questions you have in the end of the video, and we will talk soon.